4.6 is graphing the other four trigonometric ratios. We'll start with cosecant and secant. And those are just reciprocals of sine and cosecant, sine and cosine. So I went and I found my sine values, and just to remember, if you forgot your sine values, these are the 0, 1, negative 1, 0, 0, negative 1, and then sine is y. So I just go around the circle and use my y values. And then when we reciprocate 0, you get undefined. So I've got 3 undefineds in here. With your hands, I want to show you some what's going to happen when we go from sine to cosecant with your hands. If you could go ahead and make a sine graph. Okay, and if there was a person watching, I don't know if I can try to do it on here. Here's my sine graph. Yeah? Okay. When I reciprocate it, what's going to happen is this sine graph is going to go like, I'm going to do it in front of you guys first. It's going to go, so my fingers, my thumb, where they're holding together, they're just going to like separate and go the other direction. I'll see if I can do it under here. My angle is off a little bit. Okay. That. That's hard to do under the camera. So anyway, what's happening is we have this nice smooth curve, and then it's going to break apart, and we're going to have 2 pieces. So every place that you see an undefined, these become asymptotes. And they're always written as x equals, and then to get that x equals, you're looking at the x value of that row. And asymptotes would be like an imaginary border that the graph is not going to pass through, but it's using the asymptote to form. It's approaching that asymptote. And as I graph the first 3, I just couldn't help myself but keep going, because this is a periodic graph. It will repeat over and over and over again. It will keep the same spacing. So once I've graphed those first 2 asymptotes, there's 3 of them, first 2 asymptotes, I can graph all of them. And we have to write the equation of the asymptotes. So there are infinitely many asymptotes because this goes on forever. So there's no way I can just write down every single asymptote that there ever was. So we'll have a formula instead. And the formula is going to start with, we're going to always do x equals. And you're going to write, first you're going to write the first non-negative asymptote. So we're going to write the first non-negative asymptote. So up here, what is our first non-negative asymptote? 0 is the first non-negative. Pi is also non-negative, but 0 is the first non-negative. So I'm going to write 0 plus, but I'm not actually going to write 0 plus, because 0 plus anything, 0 doesn't have to be there, so I'm not going to write it, but I am writing it, okay? It's not always going to be 0. And then what we're going to add on is the difference between the asymptotes multiplied by a variable, so that we can get each asymptote after there. So the distance between these asymptotes is how far? Can't hear you. Pi. So the variable we're going to choose is k, so we're going to write 0 plus pi k but just writing 0 plus pi k is not enough, because what if k is 1/2? That would not work, because this is 1 pi apart, not half a pi. So we have to limit the numbers at which k can be. What kind of number should K be? They're going to be integers. So I'm going to have a comma on this line in a moment. I'm going to have a comma, and I'm going to write that K is an element. K is an element of the set of integers. But I'm not going to write all that. I'm going to write it using symbols because that's a lot. And I don't know if you've noticed, but mathematicians have shorthanded everything. So we're going to write K as an element of the set of integers, but I'm not writing it all out. So I'm going to put K, and then is an element of, looks like this. And then the set of integers, I'm just going to use the symbol that stands for integers. That kind of looks like a Z with two lines in the middle. That way I don't have to write out all those words. So that's our asymptotes. Haven't actually graphed the graph yet. So pi over 2 is 1. And 3 pi over 2 is negative 1. Now, some people went ahead and said fill out the table. Well, they went ahead and graphed the sine graph also. You don't need to graph the sine graph. I'm going to do it just so you can see it. Okay, but like I showed you with my arms or my hands, that what's going to happen is these two max and min values are going to change into min and max values. They were max and min, now they're going to be min and max. So what we're going to do is we're going to draw, it's not a parabola, it definitely kind of looks U-shaped, it's not a parabola. We're going to draw these separate pieces. They go away from each other. We get the points up here by reciprocating all of the points. As it leads down to 0, if I do reciprocals, it's going to get bigger and bigger and bigger. So that's what's happening on the other side. It's getting bigger and bigger and bigger. And then we just continue that pattern. And that's what cosecant looks like, parent function of cosecant. So if it is the higher point, it will open up. If it is the lower of the 2 points, it will open down. All right, and then we have secant, which is cosine flipped. So I went ahead and filled out my table for cosine and secant, and every place that I see an undefined is now going to become an asymptote. Pi over 2, there's an asymptote. And 3 pi over 2 is an asymptote. And then once I got 2 of them, I can write the rest of them. And then 0, 1, pi, negative 1, 2 pi 1. It's going to be the same shape. It's just shifted of what cosecant was. Just like sine and cosine are the same shape, just shifted. And then those sides of it are getting closer and closer and closer and closer to the asymptotes, but they're not passing through the asymptotes. For the asymptotes, we're going to write x equals. We're going to start with the first non-negative asymptote, which is at pi over 2. And we're going to add on how far apart they are, which is pi times k. But then we need to specify that k is an element of the set of integers. And now you have parent functions. Should they have some babies? Because they're parents? No. No more transformations. Okay, so we'll do transformations. Oops, it's on the back. So this is how I do them. Some of you are like, don't need to do this, I know this, but I make silly mistakes if I don't like write everything down. So when I go and I see that this is cosecant, I have to think to myself, well, that's sine. So I usually write it down. And then what I do is I actually write down the sine values right in the corner here, just so I remember them. And then I reciprocate them. And the reason why I do all that, so I don't have to memorize as much, because there's a lot to memorize, and so I'm having my brain concentrate on more important things, because I can figure this out on the spot. All right, 3 cosecant x plus 2. So if we have a 3 in front, what kind of transformation is that? Vertical stretch. We're going to multiply all of our y's by 3. Ooh. Undefined times 3. I have in my possession a vertical line. I do. So I can show you what happens when we stretch a vertical line vertically. See my vertical line? Okay, so there's something you can't really see on my vertical line. There's something you can't see at the very edges of the vertical line. What are my fingers covering up? Arrows, because what happens to this line? It goes on forever, never stops. So there are arrows there. Now I'm going to stretch it vertically. Here we go. I stretched it. What happened to the vertical line when I stretched it? It's still a vertical line. It's still there, right? Okay, the next thing we have to do is add 2. So I'm going to go ahead and add 2 to my vertical line. You ready for this? What happened to the vertical line when I added 2? Still a vertical line. So when we do y stuff, vertical stuff to the vertical line, nothing changes. So this is going to remain undefined all the way over. Oh, I didn't really say anything. I should probably tell you. UNDF is not an official abbreviation, but it is one that I will allow you to use. Don't make up your own. Don't use anything else. There is not a for real symbol for undefined. Okay? Do not use the symbol for no solution. There's not a symbol for undefined. But if we have to type stuff in Canvas, I'm okay with you writing UNDF instead of writing out the entire word of undefined. But I'll put both as an answer. Okay? All right. So we have our multiply by 3, our plus 2, and that's everything. So we'll go ahead and graph our asymptotes, which are at 0, at pi, at 2 pi, 3 pi, so on. And since I'm doing my asymptotes, I'm just going to go way down here and go ahead and answer what my asymptotes are. So x equals, what is our first non-negative asymptote? 0, so I'm not going to write it, it's there. Plus, we have to say how far apart they are. Pi multiplied by k. And then that's where k is an element of the set of integers. All right, back to my graph. Pi over 2 is 5. 3 pi over 2 is -1. And then we just follow a pattern. you're just graphing these are super easy to graph. I would rather you pay more attention to writing the stuff out. You can always throw those graphs up there later, okay? If you've got a couple of them graphed, that's fine. So now we're going to answer questions about this. We're going to start with period. So since these are just coming from sine and they're reciprocated values, that changes nothing about the period. So the period is still 2 pi. Unless we have a horizontal stretch or shrink, which we did not. So the period is still 2 pi for this one. Phase shift is the shift left or right, which didn't have one. So I don't leave it blank. If we didn't have one, I'm just going to write none. That way I know that you know the answer. I don't think that you just left it blank. Excuse me. Vertical shift, we did vertically shift. And where did we vertically shift? Up to. So like that, if you were going to write that on Canvas, that would be allowed to have a space. Domain. So the domain would be that we have graphed, all the x values that work in this equation, starting from left to right. It's all the green stuff, if you can tell the color difference. Somebody wants to talk, but I don't know who, because I can also hear that noise over there. Christopher wants to talk.
All real numbers except for the asymptotes.
It's all real numbers except for the asymptotes. Now, we've been doing interval notation. If I want to write all real numbers except for the asymptotes in interval notation, I would need one of those brackets or parentheses for every single separate piece horizontally, all the way through. Like I would need a separate one for this one, and 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 infinitely many of them. Because of that, I'm not going to write it in interval notation because we can't. So we will write this one in set notation, which are basically just saying that x does not equal the asymptotes, pi over k, where k is an element in the integers. So if you can get your asymptotes, then you can get your domain. The range is how far down and how far up. And when we look down to up, you'll see that there's a whole down section, which in every little section it's the same. So we only have to say it once. And then there's this whole up section. So there's 2 pieces to the down and the up. So I am going to write this in interval notation. I'm going to start with negative infinity. And it's going to go all the way up to -1, where it stops. It does equal -1. So that'll be a bracket. Union, and then we start again all the way up at 5 with a bracket, and it goes to positive infinity. So where we did sine and cosine, where they were their range were in between a bracket like this. Now cosecant and secant, the range is bloop, brackets go that way, just like the graph went bloop, that way. Okay. Next, we're going to graph -2 secant x minus pi. I'm going to do it over here on this table. Secant is cosine, so I always want to think that's cosine. I'm going to write down my cosine values before I start because I make mistakes if I don't. And then I reciprocate each one. We have a -2 in front, so that's going to be multiplying everything by -2 on the y side. So undefined times -2, still undefined. If I have a reflection, sorry, I got to grab my line out again. If I have a reflection in the x-axis of the vertical line, still vertical line. And then we've got x minus pi. Remember, for horizontal, we changed the sign, so that is going to be plus pi. And then I'll go put my, that's not right. Oh, never mind. This isn't right. That's my mistake. It's not the green one. I forgot my stylus today, so I had to do it on paper. Don't know where my whiteout is. Sorry. Okay. So 3 pi over 2 and then 5 asymptotes, and then from there I will follow the pattern. And so my asymptotes are going to be x equals, my first non-negative asymptote is pi over 2. Plus, they are pi apart, so pi k. K is an element in the set of integers. Okay, and then I'll go ahead and graph pi negative 2. Um, 2 pi is 2. 3 pi is negative 2. And then I'll just finish my pattern. So we didn't have a horizontal stretch or shrink, so the period is still 2 pi. Phase shift, we had a right pi. Vertical shift, we did not have one, so I will write none. Domain is going to be the same as the asymptotes, but not equal to. And then the range is going to be in 2 pieces. Infinity to negative 2 with the bracket, union 2 to infinity. The middle 2 numbers have the brackets. Yes, Bill?
So if the period was bigger, would that affect the asymptote?
Mm-hmm. And the very next one has that example. So let's do it. So we're going to graph y equals secant 1/2 x plus pi. So the first thing I'm going to do is secant is cosine. So cosine is 1, 0, negative 1, 0, 1. So we get 1 undefined, negative 1 undefined, 1. And what am I going to do next for transformations? What? Multiply the x's by 2. We have a horizontal stretch by a factor of 2, so I'm going to multiply those x's. And then after I multiply my x's by 2, oh, I definitely thought there was a ghost coming in. Sorry. Did you need to learn some math?
No.
Oh, okay. You just wanted to. You didn't need to. You wanted to. Do you need me? Yeah. Yeah. Yep. All right. What's the next transformation we need to do? Subtract what? Ooh, I hear pi and I hear 2 pi. Why would somebody be saying 2 pi? Because we have to factor. Yeah. So we've got secant 1/2 x plus 2 pi oh, okay. It's not a quarantine situation.
No.
Okay, that's good, because that would be his second one. I was so afraid he was getting quarantined. Okay, back to this. So we are going to be subtracting 2 pi. So now I'm going to put my asymptotes in. Oh, of course I was recording that whole conversation too. Negative pi is there, and pi. And then once I have 2 of them, I can find more of them by just following my pattern of how far they are. At negative 2, it's 1. At 0, it's negative 1. At 2 pi, it's 1. And the point that is higher will open up. The point that is lower will open down. And so we have a graph. So I'm going to do the asymptotes first. It's going to be x equals, we need to know the first non-negative asymptote, which is at pi. And then we're going to add on how far apart they are multiplied by k. So Philip, how far apart are these? How many Philips we got in here? Philip?
What's the question?
That's okay. How far apart are the asymptotes? 2 pi. So we're going to add 2 pi multiplied by k, where k is an element of the integers. I got my asymptotes. If I got my asymptotes, I can go ahead and write my domain. X does not equal. I called on you because you were asking about that just a second ago. And down here, why not? Let's throw the range in there. The range is negative infinity to negative 1 with a bracket, union 1 to infinity. All right, so our period is normally 2 pi. We had a horizontal stretch by factor of 2, so that affects the period. Period is now 4 pi. If it's distracting, you can slam it shut. No, don't do that. Ah! We didn't even get to... Oh, man, you guys are going to have to watch a video. That was fast. Okay. I guess you don't have COVID. All right. Phase shift. Phase shift, we're going to go left 2 pi. Vertical shift, there is none. All right. In 4 minutes, we're going to talk about tangent. None. All right, I'm going to talk about this, and I will have a video for you. I have a video recorded. It just didn't work this morning. But what I wanted to talk about was with tangent. So I didn't quite get to show you the graphs, but you guys with tangent, once you know the points, you just have to use transformation. Just getting the points, I just want you to understand where the points came from. If you're going to sit here and not listen to me and write all these down, you're going to miss the important part. You can write all these down later. It will be available. It's just what tangent is, okay? What I want you to notice, if I'm pointing to 0 here and I'm pointing to 0 here, if you look at the values of tangent or cotangent, in order, 0, then radical 3 over 3, then 1, then radical 3, then undefined, then negative radical 3, then negative 1, then negative radical 3 over 3, then 0. Like, they're exactly the same 2 times in a row. Because of that, the period 1 cycle of tangent is only pi long. one cycle of tangent is only pi long. And the same thing for cotangent as well, because it's the reciprocal. So tangent and cotangent are different because they have shorter cycles. Plus their points are different. So what is important that you need to write down here before watching the video to see how to graph it is for a period for tangent is pi, period for cotangent is pi. Nope. And then the key points that we are going to use for tangent, and cotangent, we're always going to use values that start at undefined and end at undefined. But tangent is not undefined at 0. So I'm not starting tangent at 0. In fact, I'll pass through 0, but I'm going to back it up. It has to be a continuous interval. So I went backwards, and we're starting at negative pi over 2, and we're going to positive pi over 2 for tangent. Those would be the key points in the tangent table, which are on the next page. And then for cotangent, we're starting at undefined and ending at undefined. So I can go from 0 to pi for cotangent. So these values are different between tangent and cotangent and different than sine and cosine. So the rest of this, I have a video, which I can post for you guys.